Welcome to Keynes on Science. This is part of my series of SLOP practice, which is sheds loads of practice on reacting mass calculations as part of your GCSE chemistry revision. Let's dive straight in. So question 1 says 28 grams of magnesium is completely burned in excess oxygen to produce magnesium oxide, and we're given the equation here. So we can ignore the oxygen because the question's about magnesium forming magnesium oxide, and we've got to calculate the mass of magnesium oxide. We've got the formula, number of moles equals mass times molar mass, so we're going to use that throughout this calculation. And the first thing we need to do is work out how many moles of magnesium. So the number of moles is mass divided by molar mass. The mass of magnesium is 28, the molar mass of magnesium is 24, so it's 28 divided by 24 equals 1.167 moles of magnesium. We then need to look at the ratio, and the ratio of magnesium to magnesium oxide, look at the equation, is 2 to 2, which is therefore 1 to 1. So therefore the number of moles of magnesium oxide is the same as number of moles of magnesium, which is 1.167. Finally, we need to calculate the mass of magnesium oxide, again using the formula. So the mass of magnesium oxide is the number of moles multiplied by the molar mass, and the molar mass of magnesium oxide is 40. So it's 1.167 times by 40 is 46.57. So question 2 says 10 grams of calcium react with oxygen to form calcium oxide. You've got the equation here, and we've got to calculate the mass of oxygen needed to react with that 10 grams of calcium. We're going to use the equation, number of moles equals mass divided by molar mass throughout the calculation. And the first thing we've got to do is calculate how many moles of calcium. So we've got 10 grams of calcium. The relative atomic mass of calcium is 40. So 10 divided by 40, which is the mass divided by molar mass, equals 0.25 moles of calcium. I then get to look at the ratio, and the ratio of oxygen to calcium is 1 to 2. So we've got half the amount of oxygen as we have calcium. So therefore the number of moles of oxygen is half that of the calcium. So 0.25 divided by 2 is 0.125 moles of oxygen. Again, we can use this equation to then calculate the mass of oxygen. So we've got 0.125 moles. The relative formula mass of oxygen is O2 is 16 times 2, so 32. So 32 times 0.125 equals 4 grams of oxygen. Question 3 says propane, C3H8, is burned in 48 grams of oxygen to form carbon dioxide and water. We're then given the equation. We've got to calculate the mass of propane that could burn in 48 grams of oxygen. We've got the equation, number of moles equals mass divided by molar mass, which we're going to use throughout. And the first thing we've got to do is calculate how many moles of oxygen we've actually got. So we know we've got 48 grams. The molar mass of oxygen is 16 times 2. So it's 48 divided by 32 is 1.5 moles of oxygen. We can then look at the ratio, and if we look at the ratio of oxygen to propane, we get 1 propane for every 5 moles of oxygen. So therefore, how many moles of propane? It's a fifth of 1.5, so we've got 0.3 moles of propane. We then use the equation, number of moles equals mass divided by molar mass, to calculate the mass of propane. The relative formula mass of propane is 44. It's carbon times 3 plus 8 hydrogen times by 0.3 moles equals 13.2 grams. Question 4 says ammonia is produced by reacting hydrogen and nitrogen. How much ammonia can be produced from 20 grams of hydrogen? We're then given the equation, and we've got to calculate the ammonia that can be made. The number of moles equals mass divided by molar mass is the equation that we're going to be using throughout. And the first thing we've got to do is calculate the number of moles of hydrogen. So we've got 20 grams of hydrogen, which is the mass. We've got to divide that by the molar mass of hydrogen, which is 2. So we've got 10 moles of hydrogen. We've then got to look at the ratio between the hydrogen and ammonia. So for every 3 hydrogen, we make 2 ammonia. So the ratio is 2 ammonia made for every 3 hydrogen. So how many moles of ammonia? Well, we know we've got 10 moles of hydrogen, and we've got 2 to 3 ratio of ammonia. So we times that by 2, divide by 3, and we've got 6.67 moles of ammonia. We can then use the equation again to calculate the mass of ammonia. So we multiply the relative formula mass of ammonia, which is 17, by the number of moles, which is 6.67. So we've got 113 grams of ammonia made from 20 grams of hydrogen. Question 5 says copper carbonate decomposes on heating to form carbon dioxide. How much carbon dioxide is formed from 7.41 grams of copper carbonate? Again, we're given the equation and we've got to calculate the mass of carbon dioxide formed. We're going to use the formula number of moles equals mass divided by molar mass. First thing we're going to do is calculate how many moles of copper carbonate we've got. So we know it's the mass divided by molar mass. So the mass is 7.41 grams. We're dividing that by the molar mass of copper carbonate, which we're given, is 123.5. So we know we've got 0.06 moles of copper carbonate. We can then look at the ratio of copper carbonate to carbon dioxide, and we can see from the equation it's 1 to 1. Can use that to calculate the number of moles of carbon dioxide. So that's the same. So we've got 0.06 moles of carbon dioxide. We can then calculate the mass of carbon dioxide again by using this equation, number of moles equals mass divided by molar mass. So to calculate the mass of carbon dioxide, it's the relative formula mass, which is 48, times by the number of moles, which we've got as 0.06. So we're going to make 2.64 grams of carbon dioxide. 6 says 2.08 kilograms of iron oxide reacts with carbon monoxide. We're then given the equation. We've got to calculate the mass of carbon monoxide that is needed to react with iron oxide. We've got to write our answer in grams. So we're giving it in kilograms, but we need an answer in grams. We're going to use the equation, number of moles equals mass divided by molar mass throughout the calculation. The first thing we've got to do is calculate how many moles of iron oxide we've got. So I'm going to multiply 2.08 by 1,000 to convert it into the grams. So we've got 2,080 grams of iron oxide. The molar mass of iron oxide is 160, given in the question. So 2,080 divided by 160 is 13 moles of iron oxide. Second thing we've got to do is look at the ratio. So using the equation, we can see the ratio. We're going to react 3 lots of carbon monoxide to every 1 lot of iron oxide. So the ratio is 3 to 1. So we can use that to work out the number of moles of carbon monoxide in the calculation. It's 3 times 13, which is 39 moles of carbon monoxide. We can then use the formula, number of moles equals mass divided by molar mass, to then calculate the mass of carbon monoxide. So it's the relative formula mass of carbon monoxide is 28. Multiply that by the number of moles, which is 39. So we've got 1,092 grams of carbon monoxide. So question 7 says hydrazine is used as rocket fuel. It can be made by reacting ammonia with hydrogen peroxide. What mass of ammonia is needed to make 148 grams of hydrazine? We're given the chemical equation. We've got to calculate the mass of ammonia, and we're told the number of moles is mass divided by molar mass, and we're going to use that throughout the question. So how many moles of hydrazine, first of all, is what we need to calculate. So we know we've got 148 grams of hydrazine. The relative formula mass of hydrazine is 32. So we've got 4.625 moles of hydrazine. Then we need to look at the ratio of hydrazine to ammonia. And we know it takes 2 lots of ammonia to make 1 lot of hydrazine. So the ratio is 2 to 1. So we can then work out how many moles of ammonia we've got. Well, we've got 1 mole of hydrazine, but we've got 2 moles of ammonia to each 1 mole of hydrazine. So we've got 9.25 moles of ammonia. We can then use the equation, number of moles equals mass divided by molar mass, to calculate the mass of ammonia. So the mass of ammonia, the relative formula mass is 17, times by the number of moles is 9.25, which gives us 157 grams of ammonia. Question 8 says chlorine reacts with 20 grams of iron to form iron chloride. We're given the chemical equation and we've got to calculate the mass of chlorine needed. So the number of moles equals mass divided by molar mass is the equation we're going to use throughout. And the first thing we need to calculate is how many moles of iron. So we're told from the question that we've got 20 grams of iron. and the relative formula mass of iron is 56, so we've got 0.357 moles of iron. We can then look at the ratio, and looking at the equation, we know the ratio for every 2 iron, we get 3 moles of chlorine. So the ratio is 3 to 2. So from that we can calculate how many moles of chlorine we've got. So it's 0.37 times by 3 divided by 2, which is 0.536 moles of chlorine. Again, we can then use this equation, number of moles equals mass divided by molar mass, to calculate the mass of chlorine. So we know chlorine has got a relative formula mass of 71, multiply that by the number of moles, which is 0.536, and that gives us 38 grams of chlorine. So question 9 says 108 grams of aluminium reacts with excess copper chloride to produce copper. We're given the chemical equation and we're asked to calculate the mass of copper produced in grams. So we're going to use the equation, number of moles equals mass divided by molar mass throughout the question. First thing we've got to do is calculate the number of moles of aluminium. So we're told we've got 108 grams of aluminium and the relative atomic mass of aluminium is 27. So using the equation number of moles equals mass over molar mass, we can calculate we've got 4 moles of aluminium. We can then look at the ratio in the equation, and we know for every 2 moles of aluminium, we're making 3 moles of copper. So the ratio is 3 to 2. So from that we can work out how many moles of copper we've got. So we've got 4 moles of aluminium. So we times that by 3, divide by 2, that gives us 6 moles of copper. We can then calculate the mass of copper using the equation number of moles equals mass divided by molar mass. So it's 6 moles times by the relative atomic mass of copper, which is 63.5. So the total mass of copper is 381 grams from 108 grams of aluminium. Question 10 says we've got 0.175 grams of gold reacting with chlorine. We're given the chemical equation and we're asked to calculate the mass of chlorine needed to react with 0.175 grams of gold. We've got to give our answer in milligrams. The equation we're going to be using is number of moles equals mass over molar mass throughout the question. And the first thing we've got to do is calculate how many moles of gold we've got. So we know we've got 0.175 grams of gold. We know the relative molar mass is 197. So that gives us 0.089 moles of gold. We can then look at the ratio, and we can see the ratio is 3 lots of chlorine for every 2 lots of gold. So therefore, how many moles of chlorine have we got? Well, it's 0.089, which is how many moles of gold we've got, times by 3, divided by 2, gives us 0.0013 moles of chlorine. From that, we can then calculate the mass of chlorine. We know we've got 0.0013 moles of chlorine times the molar mass, which is 71. So that gives us 0.0946 grams of chlorine. The question wants us to give this in milligrams, so we need to multiply that by 1,000 to give us 94.6 milligrams of chlorine. Question 11 says 120 grams of magnesium reacts with excess iron chloride solution. We're then given the chemical formula. We've got to calculate the mass of iron produced in grams. We've got the equation, number of moles equals mass divided by molar mass, that we're going to use throughout the question. And the first thing we need to calculate is how many moles of magnesium we have. So we know we've got 120 grams of magnesium. We know the molar mass of magnesium is 24. So number of moles is mass divided by molar mass. So it's 120 divided by 24. So we've got 5 moles of magnesium. From that, we can look at the ratio, and we know from the equation that 2 moles of iron are made for every 3 moles of magnesium. So the ratio is 2 to 3. We can then calculate how many moles of iron we've got. So it's 5 times 2 divided by 3. So we've got 3.33 moles of iron. Again, we can then use the equation, number of moles equals mass divided by molar mass, to calculate the mass of iron. And the mass of iron is the number of moles, which we've just calculated, 3.33, times by the molar mass, which for iron is 56. So we're going to make 186.48 grams of iron from 120 grams of magnesium. Question 12 says we've got 6 grams of magnesium. that's completely burned in excess oxygen, we've got to calculate the mass of magnesium oxide produced. We're given the chemical equation, and we know we're going to be using the formula number of moles equals mass divided by molar mass throughout the question. First thing we do is calculate how many moles of magnesium we've got. So we're told we've got 6 grams of magnesium. We know the molar mass of magnesium is 24, which gives us 0.25 moles of magnesium. We can then look at the ratio in the equation, and we can see that 2 moles of magnesium produces 2 moles of magnesium oxide. So it's a 2-to ratio, so it's 1 to 1. So that from that we can calculate how many moles of magnesium oxide we've got. So it's the same number of moles of magnesium, so it's 0.25 moles. We can then use the equation number of moles equals mass divided by molar mass to calculate the mass of magnesium oxide. So we've got 0.25 moles. The molar mass of magnesium oxide is 40. So 0.25 times 40 gives us 10 grams of magnesium oxide produced from 6 grams of magnesium. Question 13 says we've got 51 tonnes of aluminium oxide, but it's completely separated into aluminium and oxygen. We're given the chemical equation and we're asked to calculate the mass of aluminium in tonnes. We're going to use the formula number of moles equals mass divided by molar mass throughout the question. And the first thing we need to do is calculate the number of moles of aluminium oxide. So from the question, we're told that we've got 51 tonnes of aluminium, and the relative molar mass of aluminium is 102. That gives us 0.5 moles of aluminium oxide. We then look at the ratio from the equation, and we know that 4 moles of aluminium are made from 2 moles of aluminium oxide, so the ratio is 2 to 1. So from that we can calculate how many moles of aluminium we've got. Well, if we've got 0.5 moles of aluminium oxide, we therefore must have 1 mole of aluminium. We can then calculate the mass of aluminium. So 1 times the relative molar mass, which is 27. So we've got 27 tonnes of aluminium produced from 51 tonnes of aluminium oxide. So question 14 says 50 grams of magnesium is completely burned in excess oxygen to produce magnesium oxide. We've got to calculate the mass of magnesium oxide produced from 50 grams of magnesium. We're given the chemical equation, and we're going to be using the formula number of moles equals mass divided by molar mass throughout the question. First thing we've got to do is calculate how many moles of magnesium we've got. So we know we've got 50 grams of magnesium from the question. Divide that by the molar mass, so the molar mass of magnesium is 24, which gives us 2.08 moles of magnesium. We can then look at the ratio in the equation, so we know that 2 moles of magnesium produces 2 moles of magnesium oxide, so the ratio is 1 to 1. We can use that to calculate how many moles of magnesium oxide therefore we've got. So we know it's 1 to 1, so the number of moles of magnesium oxide is the same in magnesium, so it's 2.08 moles. We can then calculate the mass of magnesium oxide using the equation number of moles equals mass divided by molar mass. The number of moles is 2.08. We multiply that by the molar mass, which magnesium oxide is 40. That gives us 83.33 grams of magnesium oxide from 50 grams of magnesium. Question 15 says 105 grams of calcium reacts with oxygen to form calcium oxide. We've got to calculate the mass of oxygen needed to react with those 105 grams of calcium. We're given the chemical equation, and the formula we're going to be using throughout the question is the number of moles equals mass divided by molar mass. So first we've got to calculate is the number of moles of calcium. We know we've got 105 grams. We know the molar mass of calcium is 40, so number of moles is 105 divided by 40, which is 2.625. We can then look at the ratio, and from the ratio we know that 1 mole of oxygen reacts with 2 moles of calcium, so the ratio is 1 to 2. So therefore from that we can calculate how many moles of oxygen we've got, and we've got half the amount of calcium. So we've got 2.625 moles of calcium, so we have 1.31 moles of oxygen. We can use that then to calculate the mass of oxygen. We know the number of moles is 1.31. We can multiply that by the molar mass, and the molar mass of oxygen is 16, which gives us 41.92 grams of oxygen made from 105 grams of calcium. Question 16. This says propane is burned in 16 grams of oxygen to form carbon dioxide and water. We've got to calculate the mass of propane that could burn in 16 grams of oxygen. We're given the chemical equation, and the formula we're going to use is number of moles equals mass divided by molar mass. So the first thing we need to do is calculate the number of moles of oxygen that we've got. So we know we've got 16 grams. We know the molar mass of oxygen is 32, so 16 by 32 gives us 0.5 moles of oxygen. If we look at the ratio, 1 mole of propane reacts with 5 moles of oxygen, so the ratio is 1 to 5. So how many moles of propane have we got? Well, it's 0.5 divided by 5, which equals 0.1 moles of propane. We can, from that, calculate the mass of propane. So we know propane has got a relative molar mass of 44. We multiply that by the number of moles, which is 0.1, which gives us 4.4 grams of propane reacting with 16 grams of oxygen. I hope you found these helpful. Please subscribe, and I'll see you next time.